Okay guys, so this is the iodine clock experiment, and in this experiment we're gonna need DI water, and I'm also gonna need a graduated cylinder. This is 100 milliliter cylinder, and this is specific for water. Okay, then we also need a 0.02 molar potassium iodide solution. Right, the solution is clear. It's just the flask is amber, but the solution is clear, right? And then to measure that one, I'm gonna use this 50 milliliter graduated cylinder, and it is labeled here. Okay, and then I'm gonna need also the 0.01 sodium sulfite solution, 0.01 molar sodium sulfite solution. This solution contains starch, and starch is just the indicator that is going to help us to see the change in color. Now, if you see this solution is kind of cloudy, and I have to shake it very well so the starch is going to be completely homogenized. You see it's kind of cloudy, right? And to measure that, the amount of sodium sulfite, I have this 25 milliliter graduated cylinder. I also have my 250 milliliter beaker on top of a white paper. I have my cell phone as my timer, and I also need a stirrer, right? Because we need to stir the two solutions to start the reaction. Okay. What I'm gonna do now is to show you how the color is gonna change. Okay. So these are just random amounts of water, potassium iodide, and sodium sulfite. Doesn't matter. The only thing I want you to check is the change in color, or the final point, or the initial point where the reaction is going to start. So, because in the next experiments, I'm just going to let it run, and you guys are going to have to pause the video when you detect the change in color and take the time. I'm not going to pause the timer for you, all right? So, in the beaker, I have some potassium iodide and some water. The amounts right now are not relevant. I'm just going to show you once again the change in color. Over here, I have some sodium sulfite. Okay? Now, I have to make sure my sodium sulfite is perfectly homogenized, right? There. And then I'm going to start the timer at the same time I add the sodium sulfite. All right? There. And then I'm going to stir the mix for 5 to 10 seconds. That was 10. And then we're going to wait until the sample changes in color. If you see everything is clear right now, we're suddenly going to see a change, and that's going to be the time at which the reaction starts. You have to take that time, okay? See? So if this was our real run, you would have to pause the video when you saw the very light, the lightest shade of, it is a mix of blue and yellow, although in the video it looks more yellow than blue, right? So at that point you would have to pause the video and take the time in seconds in the time, all right? this is the first run, and what I want to show you now is that the volume of the the water and the two reactants is perfectly precise and accurate, because a lot of the students says that one of the sources of errors is that the volumes or the amounts were not measured properly. So I'm going to show you here that that is not a source of error, okay? Plus, the solutions, I just prepare them. They are very well prepared, so there is no error there, okay? So for the first run, we need 80 milliliters of water, and we have there exactly 80 milliliters of water. We are going to need 10 milliliters of potassium sulfite, and over there we have exactly 10 milliliters of potassium, not potassium sulfite, potassium iodide, right? And we need also 10 milliliters of the sodium sulfite solution with the starch as the indicator, right? So I can show you here that all the amounts are exact, okay? Now I'm gonna add my water to the beaker. Make sure all the water is there, so that source of error that some students include about not using all the measured water is not valid, as you see, right? Now all my potassium iodide goes there, everything till the very last drop, okay? And remember, we have to stir the sodium sulfite first, so we make sure the solution is homogenized. Okay? Now I'm ready to start the experiment. Remember, you guys are going to have to pause the video when the shade of yellow blue shows, okay? This is run number 1. All right. So 1, 2, 3. Once again, all the sodium sulfite is in, and I'm stirring for exactly 10 seconds. There. Okay? This is the second run. So in my beaker, I have exactly 70 milliliters of water. I have 20 milliliters of the potassium iodide exactly, right? So that's not a source of error. My beaker was perfectly clean, so that is not a source of error, okay? Now I'm gonna add exactly my 10 milliliters of sodium sulfite, and at the same time we start the timer, same procedure. As soon as you see that very light shade of yellow, just to stop or pause the video, okay? Now, we have to homogenize the sodium sulfite. And here we go. 1, 2, 3. And I'm starting to stir exactly at 5 seconds, the way I did it before. And I'm gonna do it for exactly 10 seconds. What do you think? Is this reaction gonna be faster or slower than the previous one? Huh? Let's see. This is experiment number 3. So in my beaker, there are 60 milliliters of water, exactly. There are 30 milliliters of potassium iodide, exactly, right? And I'm gonna add my perfectly homogenized 10 milliliters of sodium sulfite, okay? Let's see. Hold on. 1, 2, 3. Stir for 10 seconds. Last experiment. So we have here 50 milliliters of water. We have 40 milliliters of the potassium iodide solution. And over here I have my 10 milliliters of sodium sulfite, right? So same procedure. Don't forget to pause or stop the video, right? Okay, here we go. 1, 2, 3, go. Same 10 seconds. Stirring the sample. Okay,